All right, the strategy for graphing rational functions. So this is after you've kind of already learned a little bit about rational functions and taken a look at a couple things. Now we're going to kind of put it all together here and look at a strategy. And so the first part of our strategy really has to do with identifying the asymptotes. So you can see here I've got listed step one. Step one, we're locating the vertical asymptotes, and that's any place where our denominator is going to be equal to 0. That makes our function undefined at that location, and so we'll have a vertical asymptote there. You want to now compare the first terms in the numerator and denominator to identify your horizontal asymptotes. And so I've kind of given us a little start to our rational function here, and you can see in the numerator here I've got, a sub n and x sub n to some power, but that is my leading term there in the numerator, and then I've listed my leading term in the denominator. For the most part, the terms after the leading term don't really come into play a whole lot. A little bit when we're talking about slant asymptotes, but we'll get to that in a second. But for most part, you can just compare the first two terms, the one in the numerator and the one in the denominator, and from there you can kind of get at least a direction in terms of what kind of slant or horizontal asymptotes you're going to have. So let's see, kind of case one here is if n, which is the numerator, the power on n up here, right there, that guy, is lower than the power we have in the denominator. If that's the case, then as x starts to get really large, the denominator is going to overpower the numerator, and this thing is going to go to 0. And so that's when we get this horizontal asymptote at 0. So anytime the denominator is a higher degree than the numerator, it's going to end up, our horizontal asymptote will be at 0. Now, if the degrees are exactly the same, we compare the leading terms in both polynomials, and they're exactly the same, then we are going to get a horizontal asymptote. But to find it, we're going to divide just the coefficients. So you see a sub n and b sub n, those are just the coefficients on the first two terms. All you have to do is do that division, and what you end up with then will be your line y equals whatever that division is, and that will be your horizontal asymptote in that location. So you can see the trend here. Basically, we're starting out with the numerator less than the denominator. Now the numerator equal to the denominator. We're still getting a horizontal asymptote, but at some different location than 0. Now, if you get that the numerator has a degree 1 degree higher than the denominator, so notice these are just the exponents here that we're concerned with. So if this degree up here is 1 degree higher than this one, this is the case where we get a slant asymptote. And what we do is we divide the numerator by the denominator. A lot of times we'll use synthetic division to do that division, but you divide that out, and when you get done at dividing, you ignore the remainder, and what's left over after you ignore the remainder is going to be the line for your slant asymptote. That may be a little tricky to understand right now, but when I show you an example in a practice here, you'll be able to do that. Okay? So that is if n was equal to m plus 1, 1 degree higher than the denominator. Now, if we have more than that, we don't get any asymptotes at all. Okay, so if n is higher than m plus 1, more than 1 degree higher up here than it is down there, we don't have to worry about any horizontal or slant asymptotes. Once we get the asymptotes identified, then we just use all the graphing strategies that we've already been using. We use all the strategies we have, find the zeros, find some intercepts, things like that, kind of easy points to find. And then we also plot points around our asymptotes, both the vertical ones and the horizontal ones. And as we kind of plot points around there, it will become clear what the graph is going to kind of look like. And again, when we're graphing, we're not trying to be perfect, but we're just trying to get a nice sketch of these graphs. All right, now let's take all these strategies and put it to practice here. Okay, so let's see. Why don't you pause your video player here just a second. If you got to scroll back and look at those strategies, actually I'll send this out as an extra document. I'll send this document out so you can have those strategies right there next to you as you practice this problem. But give it a shot first and see how you do, and then hit play, and I'll kind of work through it, and then you can see what things you got right and maybe what things you still need to work on. All right. Well, let's first start with vertical. I think the vertical ones are the easiest to find. So our vertical asymptotes are going to occur when our denominator is 0. We're trying to find x values that make our denominator 0. If we look at our denominator here, it's pretty easy to see that, hey, that's going to happen when x equals 0. So we're going to have a vertical asymptote at x equals 0. So we'll go ahead and put that in here. Again, asymptotes are always graphed with dotted lines because they're not really part of the graphed lines. They're just kind of these boundaries, or actually just kind of boundaries on our graph. All right, now let's take a look at our horizontal or slant. So horizontal only occurs if the 2 degrees are the same or the denominator has a higher degree than the numerator. And if we look here, that's the scenario that we have. The denominator is a higher degree than the numerator. There are no x's up here, but we do have this denominator there. So we would say at this point we're going to have a horizontal asymptote. This thing is going to approach, this part of our function right here is going to approach 0 as x gets really big. So as x goes to infinity here, this f of x value is going to go to 0. So maybe not the whole f of x value, but this part right here would go to 0. So if that goes to 0, we're going to basically have 0 plus 2. Well, that 2 is going to shift this horizontal asymptote up 2. So instead of an asymptote at 0, we're going to have a horizontal asymptote at 2. So hopefully you caught that. All right. We don't have any slant asymptotes. You know, we never have a scenario where we have both a horizontal and a slant. So it's either one or the other. And so since we have a horizontal asymptote here, we're not going to have a slant. So now we're ready to graph some points kind of around these boundary lines, or sorry, these asymptotes. So let's see. Let's pick a value here. We've got it at x equals 0 and then y equals 2. Are my asymptotes. So let's kind of pick points around here and see what's going to happen. We don't want to have an actual point at x equals 0, but we do want to kind of see what's happening around it. So maybe I would go x equals positive 1 and x equals negative 1. So I come over here and let's plug some stuff in and see what's going to happen. So we said x equals positive 1, x equals negative 1. Well, let's see, when I plug a positive 1 in here, I would get 3 halves plus 2. So f of 1 is going to be 3 over 2 plus 2. So this is really, 3 halves is really 1 1/2. 1 1/2 plus 2 would give me 3 1/2. So when I plugged a 1 in there, I get 3 1/2 in. So 1 and then 1, 2, 3.5 about there. Let's see, negative 1. We said 3.5. Let's see, f of negative 1. We would get negative 3 halves plus 2. So that's going to be just negative 1/2, it looks like, because this is negative 1/2. Negative 1 1/2 plus 2 would be positive 1/2. So we're just going to get 0.5 there. So at negative 1, we're going to be up 0.5. Somehow I lost this other dot here. Let's see, that was up 3.5. 1, 2, 3.5. And you'll notice, you see we're getting symmetry here, and this happens a lot when we have, especially these horizontal and vertical asymptotes crossing. You see this point is symmetric with that across the asymptotes, not across our origin, but across the asymptotes. So let's see, let's get another one out here. Maybe let's get out here x equals 2, and then let's try x equals negative 2. All right, so we're checking out what happens when f is 2. So it would be 3. If I plug a 2 in here, 2 times 2 would give me 4. So this is really going to be 2.75. Let's try negative 2 here. So then this is, instead of being a positive 3/4, it's going to be a negative 3/4. So that is going to be a positive 1.25. So let's see, when we said 2, we had 2.25 2.75. Negative 2, we had 1.25. So at 2 over 2, 1, 2, up 2.75. So 2.75 about there. And then we said over here, negative 2, 1, 2, we said up 1.25. Okay. And I think from here you can kind of tell what's going on. If you don't see it, I'd pick another one, maybe 3 and negative 3. But what's going to happen here is we are going to approach these asymptotes like this and like that. And we're going to have the same thing over here. Whoops. Not going across the asymptote line, of course, but approaching that. Okay, go ahead and pause your video player now and let's try practice question 2. When you get done, hit play to see how you did. Alright, let's start with vertical. Let's see, we're just looking at the denominator when it's going to be 0. Looks like at a positive 1. So we're going to have a vertical asymptote at x equals positive 1. So come over here and sketch that in. All right, let's see. Horizontal. We are going to have a horizontal if the degrees match in the numerator, the leading term here, the degrees match here. When they match, then we're going to get a horizontal asymptote. And what we do is we just simplify. These first terms really kind of dominate what's going on here. So all we do is simplify the first terms and we ignore these second terms. So we're really just going to simplify this. 2x over x, which gives us a value of 2. And so that's going to be our horizontal asymptote. We're going to get a horizontal asymptote at y equals 2. So let's see, up 1, 2. All right, so we've got those two. Let's plot some points around here now to kind of see what's going on. And I think it's nice, again, just like I did last time, to pick x values that are kind of symmetric across our vertical asymptote here. So I might pick 0 and 2. Those would be 2 points of symmetry, 0 and 2. So we're going to try f of 0, which is 0 minus 1 over 0 minus 1, which is just going to be positive 1. I'm just plugging a 0 in there for x and a 0 in there for x. So I get a 1. And when I try f of 2, let's see, I would get 4. 2 times 2 is 4. 4 minus 1 is going to give me 3 in the numerator. And then 2 minus 1 down here would give me 1. So it gives me the point 3. So let's see. Over 0, up 1. Over 2, up 3. 1, 2, 3. I don't know what happened to this one, but it disappeared there for a second. Okay, and again, you notice we're getting this symmetry across our asymptotes. So this graph is really, we could sketch some more points in here, but this graph is really going to do the same thing. It's going to come down here and approach the line y equals 2 and approach the line, go off to infinity, sorry, as we approach the line x equals 1. Same deal here. And so you might have to try a couple more points to get that graph, but hopefully you did. And this one is a little different, but let's look at our leading terms here and figure out what this is going to happen here. So notice I have 2x squared as my leading term up top and then just x. So this is a case where the numerator is 1 degree higher than the denominator. So this is a slant asymptote situation. So we're going to be looking for a vertical asymptote here and a slant asymptote. And remember, we use division to calculate the slant asymptote. We're taking that numerator, dividing by the denominator. I prefer to use synthetic division when we do that. You could use long division if you wanted to. But go ahead now and pause your video player, find the vertical and the slant asymptote, and after you do that, see if you can plot some points and kind of get a sketch of this graph. When you're done, hit play to see how you did. Okay, as discussed, let's start with the vertical. That's easy. And that's just going to be at x equals 3. So I come over here, 1, 2, 3, draw my vertical asymptote in. All right, now let's try to find this slant asymptote. So what we want to do is we want to take the numerator divided by the denominator. So if x minus 3 is my factor, that means I want 3 out front. And then I'm going to have 2x squared, 0x, and then 0 for my constant term. Notice we just have one term up there, but I have to have a place in my division for everyone. So that was my x squared term, my x term, and my constant term. So I'm going to come down here. I'm going to drop the 2. And then 3 times 2 is 6. And then I'm going to add 0 times 6, adding 0 plus 6, which will give me 6. Then I'm going to multiply 3 times 6, which will give me 18. Adding again would give me 18 here. Now, I don't need to worry about this last spot because that's my remainder. I don't need to worry about my remainder when I'm talking about my asymptote here. It really doesn't play a role as x starts to get big. That number 18 is not going to play a role in this at all. So this is my remainder. This is my remainder. This would be my constant term, so 6, and this would be my x term, so 2x. So there is the equation for my slant asymptote. Y equals 2x plus 6. So let's see, I'll come up here, 6. 1, 2, 3, 4, 5, 6. There would be 1 point on my graph. And now, notice this is in slope-intercept form, y equals mx plus b. There was my y-intercept. Here's my slope of 2. Well, here's my slope, which is 2, and a slope of 2, remember, 2 over 1. So I'm going to come over here to my point and go up 2 in the y direction, 1, 2 over 1, 1, 2 over 1. And that gets us now. We don't want to draw this line. We want to draw it dotted because it is an asymptote. Okay, so we've got some interesting things going on here. Now, once we got these asymptotes, we're going to try to figure out what's going on. Remember, we're going to have lines approaching these things, so I'm kind of anticipating maybe something coming up like this, maybe a line coming up in here like this, or we could have, and usually with symmetry, if we get one coming in here, the other one would be up here, or we could have things coming over here on the sides this way. We won't know until we try some points to try to figure this out here. So that's what I'm going to do next. And with something like this, we're going to have to try quite a few points. So let's see, maybe we'll try something in here and see what happens. Like I'll put a 0 in there. That's an easy one to evaluate. Maybe I'll put a positive 2 in there. And then let's see what happens when I get on this side of the asymptote. So that's 1, 2, 3, 4. Let's try a 4 in there. Let's also see what happens when we get on the left side of this asymptote. So 1, 2, 3, 4, 5. That's negative 5. I'll try some of these values in there. So let's see, if I plug a 0 into the equation up here, that would be 0 over 0 minus 3, or 0 over negative 3. Well, 0 divided by negative 3 is still 0. So we get the point 0, 0 as one of my points here. Let's see, 2, when I plug a 2 into this guy, let's see what happens there. It'd be 2 times 4. I'm thinking about 2 squared is 4 times 2, and then down here, plugging a 2 into this, 2 minus 3 would give me negative 1. So it looks like this is going to be a negative 8 when I plug at 2. At 1, 2, we're going to be down 1, 2, 3, 4, 5, 6, 7, 8. All right, so it looks like this guy is curving down here, approaching this asymptote. Let's kind of keep seeing here. So that was 2. We had negative 8. Let's try f of 4. So 4 squared over 4 minus 3, which is going to give me 1. So this is going to be a very big value here. So 4 squared is 16. 16 times 2 is 32. 32 divided by 1 is still 32. So that was at 4. We were going to be up 32. So, positive 4. So 1, 2, 3, 4. We're coming way up at 32. So it looks like now you can see that we're going to cross this asymptote up here. And as I talked about before, we get a lot of symmetry across the asymptotes. So whatever shape we're getting down here on this side, we're also going to get that shape up here on this side. We won't have anything going on over here or anything going on over there. So really we'll just create this shape and then try to reproduce it up here, and it's really going to kind of go off the page, so it's really not something we would try to graph. These values are going way off the page. If we get this part down, that's good enough. So let's kind of see what happens over here. 1, 2, 3. Let's try -3. So f of -3. It's going to give us 2 times -3 squared over -6 in the denominator. So this is 9 times 2, 18, divided by -6 is going to give me -3. So -3, 1, 2, 3, down, -3, 1, 2, 3. So this is enough now to kind of sketch the graph out. We know that we're going to be approaching this asymptote down there, and we know that this guy is going to approach that asymptote there. If this graph had been a little bit, this crossing had been a little bit closer down here, and we could have some points up here, we would find the same symmetric shape up here on this side. But again, as I mentioned, it's really going way off our graph, so we wouldn't even try to graph that.